Hello and welcome back to the channel. Today we're going to talk about unsaturated fat and particularly the difference between trans fats and regular unsaturated fat, because trans fat is an unsaturated fat. If you haven't already watched my introduction to fats for dummies, you should do that first, because this is a continuation of that one. I will try to link it in my comments or description. The thing is, when I usually add links in my description, YouTube tells me I'm not authorized to do that, but I will try to put it in the comments. So anyway, let's get started. There has been a lot of misconception and misthoughts, misbeliefs, everything about fats, and in particular trans fats and unsaturated fats in general. So where fats are present is in the cell membrane. And saturated fats are quite stable, quite strong. They're resistant to radicals and those type of things. But unsaturated fats are much more sensitive. And that's a key thing here, because the body needs to protect the unsaturated fat with more antioxidants since they're more vulnerable. Antioxidants are like samurais or warriors, gladiators. They have a sword and they have a shield. And they are protecting whatever is vulnerable in your body. So if we look at how these fats look in more detail, and I know this one is a bit more advanced than the basic ones, it might not be for everyone, but if you're curious, I will try to make this chemistry as easy as possible. This is a fat, saturated fat, and they are straight, and each gray thing here is a carbon. So if you count the carbons, you see like, this is 18 carbons, and then it's this type of fat. So the number of carbons is giving the name to the fat. Like butyrate will just be here, 1, 2, 3, 4. It will just be to here. That's butyrate. It's just 4 carbons. If we look at a typical unsaturated fat, monounsaturated in this case, you can see on oleic acid, it looks the same, but then you have here this double bond, there are 2 bonds, and that bends the molecule like this. And that means if you look at how far this one reaches from here to here, this one doesn't reach as far. You still have this distance here, which is not covered. So that means that unsaturated fat that are used in cell membranes, for them to get the same length as the saturated ones, they need to be a little bit longer and maybe have 2 bonds. It goes all the way here, because this is the distance you need to cover when you do your work in a cell membrane here. You have all these fats starting at the surface going to the middle. Here is an enlargement of that. But because of this band, you can see here how there's 2 of these white things that hydrogens on each carbon, here. But where it's have a unsaturation, there's a double bond, there's just 1 carbon. And this creates some space here, less protection. These carbons are like shields. They protect the bonds. But here you have less shields, so radicals, sunlight and other thing can easily come in here and break one of these bonds and start a radical reaction. That is why we have antioxidants to protect from this to happen, and if it happens, to take care of it. But these ones are more susceptible for that. And the body knows that and feels that, and therefore use them in places where you do not need to have so stable fats, and it's protected by antioxidants. And this is often why some supplements come with astaxanthin or some fancy antioxidants together with polyunsaturated fats like omega-3s, to make them stable. They will not be stable as a supplement otherwise. Now, there's something called CLA, that is conjugated fats. And often you hear that trans fats, in the past, if we rewind like 20 years, the authorities and the general idea was that trans fats are not problematic at all. But after a while, and trans fats were often labeled, they were counted as saturated fat. So when there comes some data on the saturated fat might not be so good for your health, in fact it was the trans fat causing those issues, because the label didn't separate them. It is an unsaturated fat, but was counted as saturated for some reason. Here is an example of a trans fat. And as you can see, it's straight as the saturated fat. But it still has one double bond here, but you don't see it so easily. Here you see it's bent and you see where the double bond is. But here it's a little bit hidden. But there's still a double bond, which means less hydrogen for protection. So this one is also vulnerable. But the body doesn't see that. The body is very much a geometrical thing. Enzymes and things are very much three-dimensional. They're like you putting hand in your glove. If it's the right one on the right glove, it fits if it's the right size. Unless you do the O.J. Simpson thing and the glove doesn't fit. Or if you take the left on the right, it will not fit either. So the body very much feels and makes decisions based on how things are three-dimensionally. And these look the same. So the body will put this trans fat, where it normally puts saturated fat, in cell membranes that are exposed to heavy environments, like the skin cells where sunlight hits, or things like that. But this one is weak, this one is strong. So you fool the body to put that this is strong material, resistant material, that it puts in vulnerable places and then it breaks. And that is one of the reasons, the main reason actually why trans fats are so bad for your health. But today, fortunately, in most countries, these are sometimes on the label or even restricted by law how much you can have in food. And they are formed mainly in industrial processes when you're saturating oils. And the saturation doesn't go all the way, you end up with trans fats. It's also called partially unsaturated oils. Which was even very popular just a decade or two ago. You could see it on all levels, because anytime you had plant-based or vegetable oil, it was healthy. It didn't matter if you went to a factory that looked like shit and they did all kind of chemicals modification with it, it was still considered healthy. And some people still today think it's healthy to eat chemically produced, not naturally occurring fats. So in this process you saturate fats, and even the saturated one you produce are often not of the same proportional length as the natural ones. It's also them, if you eat a cookie with saturated fat, it's not always the same proportion of saturated fat as if you eat a beef that have some saturated fat. Even though the most common fat in beef actually is oleic acid, which you have in olive oil. Anyway, the defense here has been, first they said this is good, there's no problem with it because it's unsaturated fat. Then they had to change their mind, said trans fats are not good. But then they also said, yeah, but then trans fats in milk and beef are not good either. So then we should just drink soybean milk. But here is how natural so-called trans fat looks like. CLA stands for conjugated linoleic acid, and most naturally occurring trans fats are conjugated. And do you see a difference here? You see how it's bent, just as a normal unsaturated fat. It's bent so the body knows it's an unsaturated fat. But it's not only that, and the reason it's called a trans fat, it's just nomenclature. Because if it's straight, it calls trans. If it's bent, it calls cis. Because trans is because you have one hydrogen on each side, here they're on the same side, and cis is the same side, and trans is on opposite sides. If you look here, conjugated fats have two double bonds, and the first one is in the trans position, and the second one in the cis position. So therefore it's called T10, C12, trans 10, cis on 12. 12 is the number of the carbon number. But you can see it's bent as this one, so the body knows it. But it's not only that is incorrect here. It is so that when you have double bonds alternating every second like this, like they are here, that means they're conjugated. And for a chemist, that means that the double bond is actually delocalized. There is no double bond here or here. They're spread out, they're moving around in this section. And then we cannot draw that. We can do computer simulation on it, we cannot draw it. So for drawing purposes, we draw one trans bond and one cis bond. But in reality, there is no double bond here or here. They are moving around. That was the C stands for conjugated. So if you look that up on Google, conjugated double bonds, they are delocalized. They move around. They're not in one single place. So you have then those people who doesn't know chemistry, but they have taught a little bit in medical school, which they hardly don't remember. And then they go here and look and see, it's a trans bond, and if trans fats are bad, which we had to agree upon after 20 years, then this is also bad. But we just draw a trans bond. There is no fucking trans bond there in reality. It's a conjugated fat. It's a fourth category of fat. We have saturated, we have monounsaturated, we have polyunsaturated, and we have conjugated fats. It's a fourth category of fats. It's not a trans fat. So chemically, it's a different type of fat. Biologically, it looks different. It's bent, so the body knows it has some double bonds, even though they're delocalized. There are double bonds there, but they're not in any trans position. They are in this cloud moving around. So the misconception comes from people that doesn't have a real degree in chemistry, pretended to be chemists, and then they draw all kind of incorrect conclusions about it. And then we have to wait another 20 or 30 years before they can read the clinical data that shows that they are different. And there is already plenty of clinical data showing the difference between those fats. But there were that 20 years ago also on the trans fat versus conjugated fat, and trans fat versus saturated fat. Those data were present even 30 years ago in the 90s when I did my studies. But back then it was just consensus that they had just decided how things are. You don't need to do more research on it. It really was like that. You were not allowed. I actually tried to do a PhD on trans fats, and they said, no, there's no point to look into that. We already know everything about it. So as soon as this consensus and they do not even give you funds to do research on a topic, well, we often turn out to be wrong on those topics, don't we? Like there's so much consensus now about meat is bad and all this plant-based also so good. I guess in 20 years we can talk again and we can see how wrong everyone were about that. Anyway, so this was a little bit more of a deep dive of fat. If you're totally confused, maybe the Fat for Dummies is easy for you. That is just overall a little bit easier to digest, I think. If you like it, subscribe, comment, and let me know if you have questions. I can do quite many videos on fats and other things also. But I just had this day where I thought I will do a few videos on fats today. So thank you for watching today, and see you soon again.